Welcome back to
5.3.
part 2 of trigonometry.
What do they say? They say determine without using a calculator the value of. So look, we have cos of a plus 55 times cos of a plus 10 plus sine of a plus 55 times sine of a plus 10. So let's look at the mark allocation is 3 marks. Let's look at our brackets. I have a plus 55 here. Look how I have a plus 55. They are the same. I have a plus 10. Look how I have a plus 10. They are the same. Okay. That is kind of telling me something. Yeah? I have cos, sine. That's a
double angle identity.
That's a compound angle, not a double angle. Compound angle. Yeah?
Yeah.
But then it is the expanded version of the compound angle. So what I can do now, I can simplify it. Ne? So I will just say, okay, I know basically this comes from the compound angle cos. Ne? So it's basically cos A minus B, right? Because I will have cos A cos B plus sine A sine B. Like what? So I'm giving this part the second part. What I'm going to do, I'm going to take it back to the first part. So once you get something like this, you just want to simplify it. But others, now, auto one by one are okay. Cos A, cos 55, and then minus sine A, sine 55. Once you do that, you are done. Focus fate. Well, this they can easily get you. They can easily get you with this question. So once you do that, you are done. You are done. Ne? So that's why I'm saying just what's this? Try and simplify it because already it's clear. Ne? And I have now cos and be careful, ne? A plus 55 degrees minus okay, A plus 10 degrees. So when we expand it, it's gonna take us back there. I have cos ne? A plus 55, but then here it's going to be minus A and then a minus 10 because I must distribute the negative to both sides, to both guys. So that's why now I'm gonna have A canceling each other out. So I'm gonna have cos of 55 minus 10. And cos of 55 minus 10, that's just cos of 45. Ne? Then that's a special angle. Then I know that cos of 45 is just what? Root 2 over 2. Ne? Or 1 over root 5.4. Consider they give us now what's this? An equation, a trig equation. Then 5.4.1, they say prove the identity. So you know, prove left hand side is equals to right hand side. And by just looking, we must deal with our right hand side. Ne? To show it or it is equals to minus sine of x. So let me just rewrite it. So it's cos of 2x plus sine of 2x minus cos squared x all over sine x minus 2 cos x. So yeah.
Yeah, 1 minus 2 sine squared x.
Yeah.
Can we try that one second? You go on something.
Yeah. Yeah. So we are gonna have 1 minus 2 sine squared x, ne? Then rara plus 2 sine x cos x, and then raringi minus 1 minus sine squared x, ne? Then what's this? Sine x minus 2 cos x. Yeah, you could have
So,
went with it. Yeah.
so cos x mo tlase ha ona gore le yona re ka e change 2 cos x re ka e change
To what?
Why something.
It's a single identity, ne? Maybe if it was 2
okay.
cos squared x, we
Okay.
could have done something.
Yeah, okay. Well,
So let's look at our numerator. So we're going to have 1 minus 2 sine squared x plus 2 sine x cos x minus 1 plus sine squared x. So let's put our like terms together. Let me start with 2 sine x cos x. Then I have minus 2 sine squared x plus sine squared x. That's just going to be minus sine squared x. Ne? Then I have 1 minus 1. They're cancel out. So basically, I'm left with 2 sine x cos x minus sine squared x over sine x minus 2 cos x. Ne? Let's see. Do I have like terms on my numerator? I have a sine x as a like term. Ne? So I can say sine x, then you got 2 cos x minus sine x over what? Sine x minus 2 cos x. Do you see? Let me just try and do this. Oh, it could work, ne? It could work this one. So let me just put it here. So we have sine x, then 2 cos x minus sine x over sine x minus 2 cos x. So what we could do already, whatever that's in my bracket, they are almost the same. Ne? You know what? The problem is with the signs. Do we see that?
yeah.
The problem is with the signs. Ne? But what I can do on my numerator, I can take out a common factor. Not even a common factor. I can multiply everything by -1. Ne? So go back the negative, yeah, sine x. Then more I'm gonna have minus.
So why you negative -1?
Yes, because look, what is the difference between now the brackets in my what's this numerator and denominator?
Okay, yeah.
The signs are switched basically. Ne? So when I do this, get minus 2 cos x, ne? Then a plus sine x. Do you see that, ne?
Yeah. Yeah.
So that's why I'm taking out what's this minus 1. Then you have sine x minus 2 cos x. Then before we cancel, let me just pack it properly. Ne? Let me pack it properly. So you're banging sine x minus 2 cos x. Like what? So I didn't do anything wrong because why? I still kept the negative. Ne? I kept the negative. So others ukremoto unokonta the negative, then it makes everything wrong. So now I have sine x minus 2 cos x. Ne? Then you see now I can cancel the two guys. And because I took out the common factor of minus 1, now I'm left with minus sine x, which is what they were looking for in the first place. Ne? Are we? Ne? So exactly that. So 3 sine 4x plus 2, then we change it now. About 1 minus sine squared 4x is equals to 0. Then we just have to say 3 sine 4x plus 2 minus 2 sine squared 4x is equals to 0. Ne? Then I want to show you guys something. So look, I have minus 2 sine squared 4x plus 3 sine 4x plus 2 is equals to 0. So already I'm seeing a trinomial. So I'm going to have 2 sine squared 4x minus 3 sine 4x minus 2. So it can just fall away. So now I have 2 sine squared 4x minus 3 sine 4x minus 2 is equals to 0. No? So usually, let sine 4x is equals to y. But if, by the way, this is not compulsory. This type is not compulsory, making it equals to y. If you can factorize this, go for it, because it's an extra step. But then, as I said, it is better for you to do 10 steps to get 1 mark. Because when you do this extra step, you are guaranteed you're gonna get your answer correct. You won't make mistakes. So if you're unsure, then you go for it. So basically, if we are letting sine 4x is equals to y, wherever we see sine 4x, we put y. Then we are gonna have 2y squared minus 3y minus 2 is equals to 0. Sure. So now I just have to factorize. Even with factorizing like this, it's usually a problem. But I have a method that I use, and I'm just gonna show you guys. So I have now. So what I'm gonna do basically, please follow me. I'm gonna take the factors of my coefficient of the y squared, then I got the factors of my constant term or the last term. So those factors it's a 2, it's just 1 and 2. Yeah? Then I'm gonna rewrite it from backwards 2 and 1. Then I draw a line to divide. Then again, I get it as for this one, then I write for this one, it's 2 again. So it's a coincidence. So it's just 1, 2, then 2, 1. Yeah? So what I'm gonna do now, let me open my brackets. 2 brackets is equals to 0. So I'm looking for now, I'm gonna just cross multiply all of these factors. So let me change color. So I'm gonna say 2 times 1 and then 2 times 1. But then I'm subtracting them to get a factor of, to get what? 3. Ne? So 2 times 1, that's 2. 2 times 1, that's 2. Then I'm subtracting what? 2 times 1 again, which is 2. And then for 0. So I'm not getting 3. So I know these ones are not working. Then I'm going for other ones. Ne? Then I'm going to have 2 times 2 multiplied by 1 times 1. So, okay, 2 times 2. 2 times 2, that's 4. Ne? Minus 1 times 1, that's 1. In fact, 3. So I found my winner. I'm just going to circle them. Then here I am. So you see the way I get the circuiting. When I write them down now, what is here on my first line? This is basically my first bracket. Ne? Then what is here on my second line is basically my second bracket. So look, more Yamatom, I have 1 and 2. I have 1 and I have 2. So I'm gonna put y because it's like 1y. Then here I put 2. So I'm done with this first one. Then the second one I have 2y and I have 1. So good. I have 2 and 1. So I'm just gonna put 2y and I put 1. Yeah? Then it's just a matter of putting in the sign. So I know, okay, sign a negative, I will have plus and minus. Okay? Then this one is negative. My bigger number must have a negative. So look, it's like part of the foil. I'm just going to say this times this, and I got it this times this. It's basically my ins and my out. Out, in, out. So 2 times 2y, that's 4y. And then y times 1, that's y. So my bigger guy now is 4y again. So it's this one. So go out of my negative because it will be what? Negative 2 times 2y, which will be minus 4y. Then a plus, you see, so I have minus 4y plus y, which is just minus 3y, which is what I have here. So it's just my method. For me, it's not sine 4x is equal to y. So now what we are going to do, wherever we see y, we are going to put what? Sine 4x. Ne? So I'm just going to say sine 4x minus 2. Then I'm going to have 2 sine 4x minus 1 is equals to 0. Ne? Sharp. Then from here, it's just a matter of having now sine 4x minus 2 is equal to 0, or 2 sine 4x minus 1 is equal to 0. Then look what I have. I have sine 4x is equals to 2. I'm going to leave it there. Because by the I must look for what? Sine 4x is equals to 0.5. Then look here. I'm going to have now. So now my sine 4x gives me 2. So I'm going to leave it. Then let's try this. So here I'm going to have 2 sine 4x is equals to 1. Then I'm going to divide both sides by 2. Then okay, I see. I'm thinking, okay, it must be plus because I was supposed to put a plus. So it's gonna be a plus. Let me go up plus. Then more of a minus. Yeah. Yeah, ne? That's what you wanted to say, ne?
Yeah.
Minus 1/2. So actually now I am finding it then. So what I'm gonna say now, they just basically told me. So most sine 4x is equals to 2, so I'm just gonna put it's not equals to 2. So I'm just
Yeah.
gonna put that restriction.
Yeah.
Ne?